Think of a crypto wallet as more than a way to pay. It can prove who a user is, unlock the right experiences, and give AI agents trusted context for safer, more personalized interactions. You've already connected the core pieces: agents that act, wallets that sign, and payments that move value on chain. Now we'll ask a bigger question. Can the wallet become the AI's identity layer? Traditional logins rely on a password, session, or identity provider between the user and the experience. Wallets change that trust model. Instead of sharing a secret, the user signs a message to prove control of an address. That address becomes a portable identity anchor. From there, the agent can connect memory, access, permissions, and on-chain assets without creating another account. Wallet sign-in begins when the user connects a wallet to the app, but connection alone is not authentication. The backend creates a fresh login challenge, usually with a one-time nonce. The wallet signs that message locally, so the private key never leaves the user's device. The server then checks that the signature matches the claimed address and that the challenge has not been reused. If everything is valid, it issues a normal application session. A good challenge message makes signing specific and understandable. Rather than asking the wallet to sign this message, include the application domain, wallet address, one-time nonce, timestamps, and the action being approved. These details bind the signature to one app, one session, and one purpose. That reduces phishing confusion and prevents replay in another context. When possible, follow SIWE, so wallets and users see a consistent, recognizable format. After the wallet signs, the backend becomes the source of trust. It retrieves the exact challenge it issued, then verifies the message and signature cryptographically. That check recovers or validates the signer's wallet address. If the recovered address matches the claimed address, the server can create a session. If it does not match, authentication fails. The private key stays in the wallet. The server only checks proof of control. Replay protection closes an important gap. A valid signature should not stay valid forever. Each login challenge needs a fresh nonce, a short expiration window, and a stored status. Once the signature checks out, mark the nonce as used immediately, so the same message cannot be submitted again. Then create the user's session with a secure mechanism, such as a signed cookie, JWT, or server-side session store. The rule is simple: never accept the same nonce twice. Authentication proves control. The user can sign from that wallet address. Token-gated authorization asks the next question: what should this verified wallet be allowed to do? An agent can inspect NFTs, ERC20 balances, membership tokens, or allow lists, then unlock content, features, or community spaces. The design requirement is clarity. Users should understand which asset is being checked, why it matters, and what access it grants. Token gating starts by choosing the right proof. For an NFT, the agent checks whether the wallet owns a specific token or one from a collection. For ERC20 access, it checks whether the balance meets a threshold. Membership may come from a custom contract or registry, such as isMember. Hybrid gating can add off-chain roles, allow lists, or app permissions. The pattern is straightforward. Verify the condition, then unlock the matching tool, content, or workflow. A token-gated agent should never rely on a user's claim alone. It starts from a verified wallet session, then reads on-chain data through an RPC, SDK, or indexer. Next, it applies the policy. Does this wallet hold the required token, NFT, or minimum balance? Only after that decision should the agent respond. Qualified users get the premium feature. Everyone else gets an upgrade path or a clear, safe denial. Wallet identity can give an agent continuity without putting everything on chain. The address becomes a stable key linked to preferences, preferred chains, risk tolerance, saved workflows, and past interactions. But the memory model should separate public facts from private application memory. A good agent makes that boundary explicit. Users should be able to inspect what is stored, adjust permissions, and delete memory when they want a reset. Connection can also establish what a user is allowed to do. Roles may come from token ownership, allow lists, DAO contracts, or your own database. Once the role is known, The agent should filter tools, responses, and workflows before anything sensitive happens. An admin might manage settings while a member only accesses member actions. This keeps personalization useful, safer, and easier to govern. Personalization starts with a simple assumption. A public wallet address can still be sensitive. It may reveal assets, habits, relationships, and financial behavior. Ask permission before connecting a wallet to memory or long-term personalization. Be transparent about what the agent reads and why. Use only the minimum data needed, and avoid surfacing private inferences back to the user or others. Most importantly, give people control. Disconnect, delete data, and adjust preferences anytime. Here's how the pieces come together in a real product. A member signs in by proving wallet ownership with a nonce challenge. The assistant checks for the required NFT or token, then loads the allowed preferences, roles, and permissions. So when a DAO member asks for a governance summary, the answer can feel personal, but only within verified access and privacy rules. Wallet-connected agents rely on 3 building blocks: authenticate with sign challenges and secure sessions, authorize with token-gated ownership checks, and personalize through wallet identity and memory. But power needs boundaries. Next, we'll focus on guardrails that limit permissions, prevent unsafe actions, and reduce wallet-related risk.